myself Amisha Singh. Today we are going to discuss electrochemistry. Now see, as the name suggests, electro means electrical energy. Okay, and chemistry, in chemistry we talk about chemical energy. Okay, so this name consists two meanings: electrical energy and chemical energy. Okay, so what we are going to study in this chapter? We will study conversion. Okay, conversion of electrical energy to chemical energy and chemical energy to electrical energy. Now, today we are going to discuss electrochemical cell. Okay, in this chapter, mainly we will discuss about electrochemical cell, electrolytic cell. Okay, then we will see conduction, the whole concept of qualitative and quantitative analysis. Then we will see some batteries and cells also. Okay, so this is basically electrochemistry chapter. The first topic is electrochemical cell. Okay, in electrochemical cell, we will be discussing chemical energy to electrical energy. How, with the help of some reaction, we can produce electricity. Okay, that is electrochemical cell, also known as galvanic cell or voltaic cell. Okay, now another, when we convert electrical energy to chemical energy, that time we will see electrolytic cell, electrolysis we will see. Okay, so now our topic is electrochemical cell. ECE. Okay, electrochemical cell. Now, electrochemical cell, what we are doing? We are doing chemical energy to electrical energy. How, with the help of some chemical reactions, we can produce electricity. Okay, now in your syllabus, one important cell is given, that is Daniel cell. Okay, now Daniel cell is an example of, okay, it is an example of electrochemical cell, also known as galvanic cell. Galvanic cell or voltaic cell. Okay, so in this, first we will see construction. We will take two half cells. Okay, now as you know, to make a cell we need two electrodes, anode and cathode. Here also same thing we will do. Okay. We are discussing Daniel cell. Now in Daniel cell, what we are doing? We are taking zinc rod. Okay. Zinc rod, this is dipped in zinc sulfate solution. Okay. So ये हमने क्या किया? Zinc sulfate solution. Okay. And this is zinc की rod है. Okay. Simply एक zinc की rod है जिसे हमने dip किया है zinc sulfate solution में. Now see, now we will join these two electrodes. And another thing, what we are doing? क्या कर रहे हैं हम केमिकल एनर्जी, केमिकल रिएक्शंस की हेल्प से इलेक्ट्रिसिटी प्रोड्यूस कर रहे हैं, करंट प्रोड्यूस कर रहे हैं. सो हमें जरूरत है हम देख पाए कि यस करंट प्रोड्यूस हुआ है. ओके, नाउ टू मेजर दैट और टू सी दैट कि यस करंट इज प्रोड्यूस्ड, टू सी दैट वी नीड ईदर वोल्टमीटर वी कैन यूज और वी कैन यूज अमीटर. ओके, एनी इलेक्ट्रिकल डिवाइस वी कैन यूज. Okay, now see, now the circuit is complete. This zinc rod will act as anode. Okay, and this is copper rod, and this dipped in copper sulfate solution. Okay, so anode में हमने क्या लिया? Zinc rod dipped in zinc sulfate solution. Cathode में हमने लिया copper rod dipped in copper sulfate solution. Okay, now this we will discuss later. Both electrodes we will join by a wire, and in that wire we are added a voltmeter, electric device. Okay, now this is anode half cell. Okay, this part of cell we will call anode half cell. This part we will call cathode half cell. always, always. Okay, I'm telling again, always. Oxidation happens at anode, whether it is electrochemical cell or electrolytic cell. Always oxidation happens at anode. Okay, so we will also call it oxidation half cell. Now see, if oxidation happens at anode, reduction will happen at cathode. Okay, so we will call reduction half cell. Also you can see this I have drawn in left side. Okay, and this is how we represent it. Anode left side. So see, as you can see, we can also call it left half cell because it is represented in left side. So left half cell. Okay, and this one we will call right half cell. If this is left, we will call it right half cell. Now, oxidation means loss of electron or gain of electron? Loss of electron. Okay, now see here we have taken zinc. So what will happen at anode? At anode, oxidation will happen. Oxidation means loss of electron. Okay, loss of electron. Who will lose electron? Zinc will lose electron. From where? From zinc load. Okay, so from zinc load, zinc will convert to Zn2 plus and will lose 2 electrons. Now as you can see, oxidation number of zinc. Here oxidation number of zinc 0. Here plus 2. 0 to plus 2. Increase in oxidation state. That means oxidation of zinc. Okay, that means oxidation of zinc. Also see, electrons we can see in product side. That means loss of electron. Again, definition of oxidation. So at anode, what we will get from zinc load? We will get Zn2 plus in solution, and electrons will be accumulated on zinc load. Electron. Okay. Now these electrons starts moving, and they will reach to cathode. Okay. Now at cathode, what happened? Reduction. Okay. Now at cathode, reduction. Always oxidation, always reduction. Reduction means gain of electron. Reduction means gain of electron. Now who will gain the electron? Now see, in this copper sulfate solution, Cu2 plus is there and SO4 2 minus is there. Okay, so who will gain the electron? Cu2 plus ion of copper sulfate solution will gain the electron. Okay, so the Cu2 plus will gain these 2 electrons and will reduce to copper. So what is happening here? This Cu2 plus ion. Okay, now see again, if you check oxidation number here, plus 2, here 0, plus 2 to 0, decrease in oxidation state, reduction. Also electrons are presented in reactant side. Reactant side means gain of electron. Gain of electron, again definition of reduction. Okay, now what is happening here? See here, zinc from zinc load is coming to the solution in the form of Zn2 plus ion. Okay, here what is happening? Cu2 plus ion that is already present in solution will gain these 2 electrons and will accumulate on this copper rod. Okay, so this is the process happening. Now see, there is a movement of electrons. Okay, electrons are moving. Okay, now see one more thing. Here at anode, we have electrons. Electrons are positively charged or negatively charged. See, I have already mentioned sign charge. It is negatively charged. That means here anode is negative electrode. If anode is negative electrode, cathode will be positive electrode. So electron, this is important question. Okay, this is a question. Electrons are moving from negative electrode to positive electrode, from anode to cathode, from zinc to copper. Okay, from left half cell to right half cell. Like this they will ask. Now, if movement of electron is from negative to positive, then current will move in opposite direction. So this will be the direction of current from positive to negative. Okay, from cathode to anode, from right half cell to left half cell. Okay, from copper to zinc. Now, so there will be deflection in voltmeter or ammeter. So we can confirm कि yes, current is produced. Okay, now there is one problem. What is that problem? See, as you can see, zinc from zinc rod is coming in solution as so see, as we can see that zinc 2 plus ion is coming in solution as the positive charge is increasing in left half cell. Okay, similarly Cu2 plus ions are consumed. Okay, so what is remaining? SO2 minus. So relatively negative charge is increasing. See, if initially 100 Cu2 plus ions are there and 100 SO4 2 minus ions are there, so initially it was balanced. Now we are consuming this. Let's say now 50 ions are already consumed. Okay, so how much 50 ions are remaining? So relatively negative charge is increased. Okay, so here negative charge is increasing. Now see, from here electrons are going outward. Okay, movement of electrons are outward. Now see, if in solution positive charge is increasing and electrons are negatively charged, so they will attract those electrons. The solution will attract those electrons. It will resist the outward flow of the electrons. Okay, same problem here. If so in solution negative charge is increasing and electrons are coming, both are negatively charged. Now they will start repelling. Okay, so this solution, the negative charge of this solution again resists inward flow of electron. Here outward flow of electron, here inward flow of electron. Okay, now so what will happen? Our cell stops working. Now how we can resolve this problem? By introducing salt bridge. Okay, what is salt bridge? It's an inverted U-tube. See, it's an inverted U-tube. Okay, inverted U-tube. Okay, filled with inert electrolyte. Inert means those electrolyte which does not participate in overall cell reaction. Okay, we will see how we will write overall cell reaction, how we will write left half cell reaction, right half cell reaction, everything we will see. But here, what is salt bridge? Salt bridge is an inverted U-tube filled with inert electrolyte. What do we mean by inert electrolyte? Those electrolyte which does not participate in our overall cell reaction. Okay. Now, in agar-agar powder. Okay. Now, agar-agar powder. That powder we use to make it in solid, semi-solid state. Okay, semi-solid state means jelly-like state. Okay. Yes. Now, for example, we use KCl. Okay. Now, see here in this cell, in left half cell, positive charge is increasing. So, positive charge, negative ion will come. Okay, to neutralize this charge. Here, negative charge is increasing, so positive ion, A plus will go, potassium ion will go to neutralize this negative charge. Okay, now what will happen? See, in the left half cell, what will happen? The zinc 2 plus will react with 2Cl minus and form ZnCl2. Okay, in right half cell, SO4 2 minus we have. Okay, this will react with 2K plus and will give K2SO4. Now, see, while explaining the definition of salt bridge, I told you inverted U-tube filled with inert electrolyte in agar-agar powder. Okay, now inert electrolyte, I have told you that it won't react, but here as we can see it reacts and it forms ZnCl2 and K2SO4. Both salts are very soluble in water. Okay, now whenever we need K plus and SO4 minus, we will get. Okay, but they are doing what these ions are doing. They are just neutralizing that charge. Okay, they are not reacting in our overall cell reaction. They are not participating in our overall cell reaction. Okay, so this is the main. Now, salt bridge definition already told. Now, main functions of salt bridge, the very main function both the charges, positive charge in anode half cell, negative charge in cathode half cell. So the main function of salt bridge is it maintains electrical neutrality in both the half cells. Okay. Second, it completes the circuit internally. See, externally by wire, internally by salt bridge. So it completes the circuit internally. Also, it allows the flow of ions. See, as you can see, K plus is going, Cl minus is going. So it allows the flow of ions. Okay. Another thing, it won't allow the flow of electrons. It only allows the flow of ions. Okay. And another important, you can say, function of salt bridge is it minimizes junction-junction electrode potential. Junction-junction potential. Now, what do we mean by junction-junction potential? Let's say this is a complete cell. Okay. And this is partition. Okay. This is anode half cell and this is cathode half cell. Okay. Now, earlier in anode half cell, positive charge is increasing. In cathode half cell, negative charge is increasing. Okay, this is the situation. Now see, this liquid. Both are liquid. Aqueous solutions are there. So this is liquid. This is what? Junction. Where two or more things meet. That is junction we will call. Okay, railway junction. On the railway, let's meet there. Okay, same liquid junction. Okay, now see here. Charge separation is there, positive charge and negative charge. Whenever there is charge separation, there will be potential difference. Understood? Whenever there is charge separation, potential difference will be there. So here you can see charge separation is there, positive and negative. Okay, now there will be potential difference. Now this potential difference we will call liquid junction potential. Liquid junction potential. Now what salt bridge will do? See, it is neutralizing what? Here neutralizing positive charge, here neutralizing negative charge. So if it is neutralizing, that means it will reduce positive charge and it will reduce negative charge. Okay. Now if charge separation reduces, okay, if we decrease charges, okay, if the charge separation is decreased, potential difference will also decrease. Okay, so same thing we are saying. Salt bridge, what is another function of salt bridge, that it decreases liquid junction potential. Okay, it minimizes it. Okay, that is another function of salt bridge. So this is all about electrochemical cell, in which we have studied Daniel cell. Okay, Daniel cell, zinc copper cell.